I'm Tolga, from 4TD Builders. We're building a new house here, about 5,000 square feet. We're using Superior Walls, insulated version. Foundation pour today, slab pour for the basement. We have XI15 Superior Walls that have built-in R15 insulation, insulated headers and footers all around. We have 4 inches of 3/4 crushed stone underneath our Stego home, which we're using 10 mil Stego vapor barrier. That's taped all together.
So that's the green stuff, right?
That's the green stuff on the ground.
Okay.
That's Stego home 10 mil vapor barrier. And then that we finish it with, we can't bring our insulation all the way to our foundation because we want to keep the foundation on its stone base per Superior Walls requirements.
So that's the limitation of Superior Walls.
That's Superior Walls limitation. The only way they give us a detail is for us to get close with the insulation is to cut the insulation at an angle. And it's just not really necessary or worth it so much to get just a little bit more insulation in here.
And then, or otherwise lose 4 or 6 inches.
Yes, we're using a little bit of R value here, but it's not tremendous. We have the Stego wrap coming to the Superior Walls. It's actually taped on the back with what they call a Stego Tech tape. It's a double-sided tape. That's,
this is the
there's a double-sided tape behind the green vapor barrier that sticks it to the concrete in the back, the foundation, so that seals on that side. And in the front, we have, again, from Stego, Crete Claw, which is this black tape that enables the concrete to stick to the Stego on the front.
So this is just for the concrete to stick?
This is just for the concrete. Concrete doesn't stick well to the Stego because it's plastic, it's very slippery. But this is a product they have that enables the concrete to completely seal against the vapor barrier on this side. So basically on the front we have the concrete sealing to this Stego, and on the back the Stego is sealed to the concrete with their Stego Tech tape.
So how is the concrete tied to the Superior Walls?
It just sits here, basically just this. It doesn't have to be tied, it's just supporting the Superior Walls from crushing. As soon as we finish this, because Superior Walls is just sitting on the ground, it's not really attached to the ground in any way, it's just sitting there by the sheer weight of it. And what we have to do is, as soon as we pour the slab here, we can actually go from the backfill, which creates a pressure against the Superior Walls from the outside, and on the inside the slab basically holds it in place, and then Superior Walls can take the load of the house, obviously. So we have everything sealed all around. Around the round penetrations, basically Stego gives you 2 options. You can either tape it, like we did. Again, this is just for the concrete to stick to it. So we have the tape going up, but also around the tape, still a little soft. You can see the Stego mastic as a second way of sealing the vapor from coming in. When the concrete is done, we can cut the excess here and then use another layer of mastic there to completely seal that edge. And that's the same.
It's still very sticky. So is that how it's going to
fine,
persist?
yeah.
Is it?
Yeah, it never really dries hard, so it's flexible.
It's flexible, nice.
But we have the same kind of detail around all our plumbing penetrations that's coming for the basement bathroom. And then we have the same thing with our sewer pit and sump pits. Again, the concrete here will be, these are our sump pits. The concrete will be level with this top of this. They're going to kind of angle it a little bit. So we have the Stego Crete Claw right around here, so the concrete will completely seal to this. And then obviously we can seal the top edge of it, and then we can put a cover on these to act as our radon remediation later in the build.
So how is the radon getting in here? So
radon gets through the dirt. Basically, the dirt underneath the slab is open to our French drain.
Got it.
To get the water out, the way the water is going to be under our slab and the vapor, it's coming here. So we put a cover on this completely sealed, and then we can take the radon and
so basically the water conduit right here is acting as a radon conduit also.
And also, yes, a radon and vapor, and you know, so we basically, this is a hole in our vapor barrier. So we have to be able to seal it on the outside, on the inside, with the cover. And the cover we use is not just the cover that sits in, it's a cover that's bolted on, completely air sealed. So we can take that air inside here that contains radon and then push it out of the roof. If we have a radon problem. If we don't, we just use that to kind of block the vapor from coming into the basements.
And we have 2 of these sump pumps.
We have 2 of these as a backup in case this area has issues with high water tables. And the reason they're connected to each other, they're backup to each other. The reason we wanted to put 2 is we're going to have 1 sump pump with a battery backup in case of power outage. But the battery backup is a limited life, so we're going to put another one that actually, a secondary backup sump pump that actually works with water pressure. That basically works with the water pressure that you get from the city water. So even in a case of no electric and the battery being depleted on the sump pump, we still have some kind of a pump that will be able to continue pumping water just using the water pressure coming from the city. That pump by itself is not a strong enough pump to want to use all the time, and because it's also using water, it's wasteful. But it's a good backup in case, you know, our first option, electric pump, fails because there's no electricity. There's a backup battery that fails because the battery ran out. Then we have a kind of a third backup with the city water running it in a house that doesn't have a generator or anything, any kind of battery backup. No, I think that's it. You know, the concrete will be done, and then
it's 4 inches thick concrete, right?
the concrete is 4 inches thick, based on our plans. We have an R10 insulation underneath. Our walls are R15 from the superior walls. We can put another R21 inside them before we finish the walls. So we're going to have R36 inside our basement walls, which is pretty good for this area, which is replicating what we're going to have upstairs, which we'll have again R36 outside upstairs because we have a 2x6 wall that is R21 and a 2x4 wall inside that's R15. So we're going back to R36 all around, you know, all our exterior, you know, walls. After pouring is done, then the framers can actually come in and finish the interior framing for the walls we have. We can build our platforms to get ready for our stairs. And after our steel beam is set in the garage, we can actually start getting the garage ready and backfill that, and we'll be ready for that pour eventually as well.
Do you want to talk briefly about the process, how they are going to benefit the basement?
Sure. Because we are not using a traditional forced air HVAC system here, we're going to have a lot of low static ducted mini split units. That's going to enable us to be able to run our line sets and some ducting inside our trusses without having to worry about soffits or anything like that. We have 9-foot ceilings here, so we should be able to keep majority of this 9-foot ceiling without any kind of soffit intrusions. So it gives a very nice big open space without any kind of soffits coming down from the ceiling where, you know, kind of visually breaks the look of the space. Because we have 3 windows in the back, 2 in the front on that side, and then we have multiple windows with a glass door in the back. So we want to keep this as open as possible. And if we can keep our ceiling completely flat as much as we can, it creates like a nice visually unbroken space and makes it look bigger. And trusses makes it available for us because our other option was here for the loads that we need to use TGI 560s, which limits the kind of holes that we can make. So this enables us with the electrical and plumbing, make it very simple for us to be able to do all our mechanicals inside. And as you can see, these are 14-inch beams. If we needed to run even an 8-inch ducting inside them, we can do that without any problems because we have enough holes where we can go through this thing. Obviously, we can go through with our ducting through the engineered beams, but it still enables us to do a lot without having to cut any holes into the TGIs or having to deal with it, and it's just an overall easier way to do it. And frankly, these days, and obviously this changes from time to time, the TGIs versus the trusses, cost-wise, there's not that much of a cost difference to go with trusses. Requires more coordinating and more accurate framing because they're made to size. But if you have a framer that can work with that and knows how to do it, that actually is not a problem. You just have to be a little bit more organized because you can't just go pick up these from a lumber yard or get them ordered the next day. They have to be custom made and engineered. Requires a little bit more work up end, but I think you save a lot of time at the end and kind of shortens the build time.
Awesome. Perfect. Thank you.
You're welcome.